This video will discuss how to find the domain and range from functions. We're going to utilize graphs and tables. Domain and range of a function. Well, the domain of a function is all the x coordinates of the coordinate points that make up the function. The range of a function is all the y coordinates of the coordinate points that make up the function. We will identify the domain and ranges from graphs and tables. Here's our first sample table. We have our coordinate points listed in our table xy. And so we need to figure out what is the domain, what is the range, and then using our definition of function, which is a one-to-one relationship between the x and y values, where x is only paired with one y, we're going to decide if this is a function or not. So the domain, we simply need to list all of the x values that we see in the x column. We'll put that in set notation. So we'll say -6, then -5, comma followed by -2, 1, 3, and 5. Now for the range, we simply look at the y side of the table. We see we have 5, 6, 0, 2. Now 0 is in there twice, so we don't need to write it twice. We only want to write it once. And also 5 down here at the bottom has also been listed at the top. So we don't need that one. We just need these 4. Okay. Now to determine if it's a function or not, again, we have to look at the x values. Is there a value in x that is also paired up with the value of y? So -6 has 5, that's fine. -5 has 6. I don't see any x values being repeated on the left side, and therefore this is a function. If I had the same number x over here, say -6 here going to 5 and -6 here also going to 6, that can't happen because each x can only go to one value. Now let's take a look at a graph. We're going to identify the domain and range, and we're going to practice writing an interval notation. So let's start with the domain. We know that the domain is all of the x values, so we're going along the x-axis, that work for this function. So this goes off the graph, so we know that this graph continues infinitely. So as I'm going this way, I can see I'm continuing to have x values in the negative direction and in the positive direction. So the domain in this particular case is going to be negative infinity to positive infinity. And because we never actually equal infinity, we're going to use parentheses. Now the range is a bit different. So range we know goes along the y-axis. And what we'll notice is if we look at this graph crosses here at 2. But this graph never goes down here. We don't see any y values below 2. We have some going up. So as the x values go up, the y goes up. So my y starts at 2 and goes up to infinity. So how do I write that? Well, it equals -2. So I'm going to put a square bracket around it. And then it continues up through positive infinity. Remember that your interval notation should always start with the smaller number, comma, larger number. Now, to determine if it is a function with a graph, it's pretty easy to do. We can just take a look at the x-axis and draw a line up any x value. And as long as it only hits the graph in one location, in other words, there's only one y value for that x value, then it is a function. We call this the vertical line test. So in this case, yes, it is a function. Now let's take a look at another graph. We're going to do the same thing, identify the domain and the range. So now we have our graph going along the x-axis. Again, here's the x-axis. And our domain is all values that I can see being included in this graph along the x-axis. So if I start down here, I see, okay, right here I have a point, that's -3. But there's nothing down here. The graph doesn't continue this way. It only goes to the right. So as I go along the x-axis, I see, okay, so like here at 0, there's a y value for that, and so forth. So in this case, my domain is going to start at -3 and go off to infinity this way. Now it actually equals -3. So again, I'm going to use the square bracket, comma, and then positive infinity. And then the range value, so again, now we're going this way up the y-axis. And the thing that you'll notice is as I go out on my graph, my y values continue. So out here, I'm going to have some y values. I'm going to have y values down here. So it's kind of the opposite of what we had before. So now my range, with the graph going this way, is -infinity to positive infinity. And again, we want to use the parentheses. Now, is it a function? Well, vertical line test says no, because if we take the x value of 5, it has a y value up here of almost 3, and down here it has a y value also of almost -3. Same thing if we were to go to 1. 1 has a y value up here of 2, and x equals 1 has a y value of 2, or excuse me, -2. So this does not meet the function test because my x value has 2 different y values. So this is not a function test. Again, vertical line test, it can only touch the graph once. Okay, let's look at sample graph 3. Identify the domain and range. Again, we've got a graph, but look at the difference. This one, the graph doesn't go on forever. It actually stops. So our graph ends here with a solid dot, and the other end of the graph stops here with a circle dot. So we need to remember that a solid dot means that this is actually equal to this point. So in this case, it actually equals, it stops at -3,5. Whereas the open circle means it's not quite equal to it. So it counts all the values on the graph up until it touches, in this case, 0 for y. It doesn't actually quite reach that point. Okay, doesn't quite reach the 2 on the x-axis. Everything is like right before it, microscopically. So how do I deal with writing domain and range? Well, let's start with domain by following the x-axis. And as we go up every one of these, we need to see where the graph ends. The graph ends here at x equals -3. Now, if I go to the positive side, if I start moving to the right, I see, along the x-axis, my graph ends at 2. So my domain then starts at -3, and a solid dot means it's equal to, and then it continues along the x-axis until it hits x equals 2. But since it's an open circle, that means it doesn't actually equal to, I'm going to use the curved parenthesis. Now let's look at the range. So the range follows the y-axis. So as I'm looking left to right from the y-axis, I see, okay. I go down here and I see my graph crosses the y at -4, but there's no part of the graph that looks down here. So it looks like -4 is the bottom, but it continues to go up. And as I keep looking, I keep saying, oh, look, over here, the graph is still across from these y values until I reach 5. And then if I were to look across from 6, for example, there's no more graph. So my range is finite on this one. It starts at -4 down here on the y-axis, and it actually equals it because it touches the graph. And then it goes up and stops at 5, and again, it's solid, so it equals it. Now you're probably wondering, what about the right side of the graph? Well, what matters is that any part of the graph is across from the y-axis. It doesn't matter that it's not over here on the right, but on the left, I can see the graph across from 5, so that's all I need. So my range, again, I said starts at -4, the bottom point. Whoops. And I'm going to use the square bracket for -4 because it's equal to. And then it's going to go up through 5, and it equals. So I'm going to use the square bracket. And again, remember, interval notation starts with the smaller number, goes to the larger number. Now, is this one a function? Well, it has the same vertical shape as the previous one we had. So yes, this is a function. It meets the vertical line test. Every x value along this x-axis only has one y value along the graph that I can find. So yes, it is a function.